Hello, in this video I'm going to be showing you how to simulate a school of fish in Unreal Engine using Niagara particle systems. We're going to be using some very simple logic to give the effect that the fish know where they're swimming and are making decisions about where to swim and then swimming there as a group. It has this very natural look without a lot of computational overhead, so I'm going to be showing you how to do that and also how to make your own custom fish, modeling it using Maya. Then at the end we're going to see how far we can push this system and we're going to try to simulate 1 million fish. I'm not exactly sure it's going to work, but we're going to give it a try and see what happens. So let's get into it. So I'm going to be using this underwater environment to simulate the fish in. I built this based on the film Avatar: The Way of Water, and I shared that entire process in a series of live streams, and I will link the replay to that below this video. So the first thing we're going to do is make a new Niagara system. We're going to right click in the empty space, and I always like to start with an empty system. I'm going to type in ns_fish sim, and we'll open that empty system up. In the blank space, we're going to right click again and add an emitter. And the emitter that we want to choose is hanging particulates. This will give us a good starting point for the fish. Let's take a look at what we have here. If you're not familiar with Niagara simulations and how they work, basically it's a sequence starting from top and going down. So it starts with the emitter spawning and then the update of the particle and finally the rendering. And these are just steps in that process. So looking at the steps in the process, I know there are two steps that I don't need for this, and that is wind force and aerodynamic drag. Next, we're going to switch our renderer type from a sprite renderer to a geometry renderer. This way we can simulate actual little fish geometry in order to make up our school of fish. And so I'll come over here to the sprite render and we'll uncheck it. In place of the sprite renderer, we'll click on this plus button under render and type in mesh, and we will choose a mesh renderer. Right away you can see these little temporary meshes being spawned here to give the effect that the fish are swimming towards something, or rather choosing to swim towards something. What we will do is create a point in space that attracts those particles. So if we come back here under the particle update, if we hit the plus button, we can type in point, and what we want to choose is point attraction force. This is a point that will attract all of these fishes towards it. I'm going to up the attraction strength to 2, and the attraction radius I want to be quite a bit bigger, so I will make it 1000. Now you can see all of these points being attracted towards the center. So all we need to do now is create a system that will move this point around to different locations, given the effect that the fish are going to be swimming towards different points. So if I come over to this position to attraction here, this is where it's going to choose where that point is that these particles are getting attracted to. And if I choose the down arrow here and I type in add vector to position, choose this one. This original position though, we don't want it to be at 0, 0. So we're going to drop down and come to link inputs and choose particles, particle position. So now we're going to be adding a vector to the particle position. The vector though, we're going to drop down again and type in multiply. And what we want to do is multiply the vector by a float, so by a single number. Now that we're multiplying the vector that we're adding to the position by a float, we can plug into the float a sine curve. If I type in sine, now that we have that set up, let's increase the size of the vector that we're multiplying by our sine curve. So I'll increase the x to 1000 and I'll increase the y to 500 and the z to 500. And this basically chooses the area that the new position of the particle could be. So it's increasing the bounds of our possible location, if that makes sense. So now you can see the particle starting to roughly change position, but it's too quickly. We need the period to be quite a bit longer. So we're going to increase the period of the sine here to 10. And now we can see the particles starting to swim towards one position and then starting to change position. But they're still only swimming between 2 points. So to add an extra level of randomness to this whole situation, I'm going to right click on the point attraction force that I already made and copy it and paste it. So now we have 2 point attraction forces operating at the same time. I'm going to click on that second point attraction force and mess with the value slightly. I'm going to make the period 15, so it's not exactly the same as the other one, and increase the vector to 2000 by 2000, and I'll leave it at 500. This will depend on the environment that you're putting the fish into, how far away you want them to be able to swim. You can always come back here and adjust this later. So we're starting to get a pretty interesting effect, but it's a little bit hard to tell what's going on without some actual fishes in there. So I'm going to jump over to Maya and make a fish. I've made a video video on how to download, install Maya, as well as a guide around the interface to get you started. You can find that link below this video. So once I'm in Maya here, I'm going to import an image that I can model my fish to. And first I'll switch to the side camera because I'm going to be projecting this image through a camera. So I'm going to hit spacebar to open multiple views, and I'm going to be choosing the side view, side X. Then I'm going to come up to view, come down to import image, and navigate to the image that I'm going to be using to model my fish. Once that image is imported here, I can hit spacebar and come back to the perspective view, and we can see that our image is here ready to use as a reference. I'm going to move this image plane over slightly so that it doesn't overlap with my geometry quite as much, and I'm going to spacebar back over here and come back to the side view. I'm going to be using a sphere in order to model this fish. So I'm going to come up here to the poly modeling shelf and choose a sphere, and I will rotate it and scale it and position it directly over the fish, something like that. I want this to be fairly simple geometry because I'm going to be trying to simulate quite a lot of fish, but in order to create the swimming animation, I still need some geometry. So I'm going to come over here to the inputs on the right side in the channel box, and under the subdivision axis and subdivision height, I'm going to click on both of them and middle mouse button drag them down till it's something like this. This looks like a good level of geometry. It doesn't look very smooth though, so I'm going to select the geometry and come up to mesh display and scroll down to soften edge. If you don't see any of these tools up here, you need to just come to the left corner here and hit this drop down menu and choose modeling. All right, I'll come back over to the side view and hit 4 to look at my mesh in wireframe mode, and I will continue to position it directly over the fish. Now I will right click and go to vertex mode and start to move the actual vertices of the mesh using my translate and scale tools. Doesn't have to be perfect because some of the detail is going to be coming from the texture. Okay, that looks pretty good. Now I need to extrude the fins off of this shape. So I'm back in perspective view here, and when I look at the geometry at the end here, it doesn't really support extrusion very well. So I'm going to actually rebuild this geometry to be better suited to extrude my tail. I'm going to right click and choose edge mode here, choose these edges, and then I'm going to shift right click in the empty space and choose delete edge. Now that I have a blank edge, I can rebuild this geometry to extrude it a little bit easier. You're going to shift right click and choose multi-cut, and this can also be found up in the shelf here or in the menus. And I'm going to click on these two vertices, this one, hit enter, and this one, and also hit enter. Now I'm going to right click and change back to face mode, hit W and click on both of these faces, shift right click and hit extrude. Now I can extrude these edges. I'm going to switch back over to the side view so I can see it better. Remember, I don't need so much geometry, just enough to make the shape. Now I'm going to switch back to multi-cut tool by shift right clicking and choosing multi-cut and add another edge loop along this line here. I'm going to shift to snap it to the center, do the same thing on the other side, pull this vertex out to smooth this edge, and go ahead and flatten the tail a little bit. Then I'll keep dragging these vertices around till I roughly make the shape of the fin here. And if I need to add an additional edge loop here and there to make the shape that I want, I can go ahead and do that. I'm also going to squish this shape down here. And finally, I'll add one more edge loop on the end here to incorporate the fin, and I can do that by shift right clicking and choosing insert edge loop tool. I'll click in the middle here and then come over to the side view and move these vertices up. And I'll do the same on the bottom. All right, I think this shape will work pretty well for us. I'm going to go ahead and come out to edit and delete all by type history, which will delete any modeling history I have on the mesh. I will come to modify and freeze transformations to freeze all of the movement I did on the sphere. And then finally, I'm going to select it again and come up to mesh display and soften the edges as well, and go ahead and delete the image plane. So now we have a simplified mesh for our fish. The last thing that needs to be done is we need to really quickly UV it. So I'm going to select it, come up here to the UV editor window in the poly modeling shelf. If I click it to open it, I'm going to come over here to create, and the planner option here, I'm going to shift click on it so I can get some options, and I want to project it from X project, so it's going to project it from the side here. And if I switch it back to object mode and I come up to the rendering shelf up here and assign it a basic material, a blend, which is this button up here, then I can come to blend. I can come over here to the attribute editor on the right side, click on the color, the checkerboard button next to the color input, choose the file option, and then input my texture. Now that it's imported, we can actually see it showing up in the UV editor. So if I expand the UV editor, I can right click on the UVs and choose UV shell. So I can select the whole shell, and then I can use my scale and translate tools to move the UVs directly over top of the fish. Now, if we come back to our viewport here and we hit 6, we can see the geometry with the texture on top of it. This is going to be good enough for our simulation, but you can use all of these techniques to make as detailed fish as you want or different kinds of fish. It's up to you. I'm going to select the geometry, come to File, Export Selection, and hit the option box. And we want to choose FBX Export as the option. If you don't have that option, you can come up to Window, Settings and Preferences, and Plugin Manager. And if you type in FBX, you need to make sure FBX Maya is loaded as a plugin. So we're going to go ahead and choose Export Selection. I will call this Blue Fish and hit Export Selection. Back in Unreal Engine, we can come and import that mesh. So if I come over to the Import button here, navigate to our Fish FBX, choose it and hit Open and choose Import All. It's going to import our fish mesh here as well as a material with the texture that we assigned in Maya. I'm going to come over here to the material and I'm just going to rename it M_Blue Fish. Now we can come back to our Niagara simulation and come to the mesh render section, and under the mesh rendering we can drop down the meshes option here and we can see this is the mesh that it's using currently. We can now drag in our fish geometry and you can see the fish are now being simulated as particles. However, there's a problem, and that is that they are not pointing in the direction that they are swimming. That can be fixed here by coming over to facing mode under the mesh renderer and switching it to velocity. They're now going to be pointing the direction that they are swimming. But if you're modeling your own fish mesh, you may not have modeled it in the same direction that Unreal Engine is using as forward, but that could easily be fixed. I can see here that they're swimming to the side, so I need to just double click on my mesh to open it and scroll down here till I come to Transform, Import Rotation. So I'm going to come over here to the Z-axis and type in 90, so it will rotate the mesh 90 degrees on the Z-axis, and choose the Re-Import Mesh button. Now you can see it's re-imported the mesh with that slight rotation. So if I come back to my fish simulation, they are now swimming in the direction that they are simulating. And let's drag it into our environment here to see how it looks. All right, so they're starting to swim, but we're noticing some strange behavior. Sometimes when the fish are spawning, they're spawning in strange directions, and that's because we're choosing the rotation of the fish based on velocity. And if the fish does not have any velocity when it's spawned, it won't know what direction to point. So we need to add some initial velocity. So come up to the particle spawn here and choose the plus button and choose add velocity. So this is a velocity in a direction that we could add. I'm going to zero this Z axis and drop down here and type in random because I want it to be a random velocity, and we'll choose random range vector. Minimum and maximum, you can play around with this based on the look that you want, but I'm going to choose between -10 and 10 on all of the axes and XYZ. So now you can see when the fish are spawned, they will just be swimming in a random direction and then they'll gradually change direction towards the flow of the rest of the fish. So it has a much more natural look to it. So we're almost done here. The one thing I want to add in here is to scale the meshes over time, because even though we don't necessarily want the fish to scale, we do not want them to pop in when they first come alive as a particle. So to get around that, I tend to add a little bit of scaling in the beginning so they scale up into existence, and then when they die as particles, they scale down, and it kind of gives the effect that the fish is just sort of swimming away into the distance. So I'm going to come up to particle update here and type in scale mesh, and we want scale mesh size here, and this is going to be a vector, so it's going to switch it to 1 by 1 by default. We want to choose the drop down here and type in multiply and grab multiply vector by float, and then next to the float choose the drop down again and type in curve, and we want float from curve. So this curve is going to affect how the meshes scale over time, and I'm going to choose this preset on the right side here and choose the point in the middle, right click on it and select weighted tangents, and this is going to let me pull these tangents out so that this fish is mostly its normal scale almost the whole time, but right at the beginning it's going to scale up and then scale down. So you're not going to see any adjustments because there's one thing we have to do in order for the scale mesh to work, and that is to come up to initialize particles, and under the mesh attributes here, we need to choose a mesh scale mode, and we're going to switch it to random uniform. So now the fish will actually be a little bit more random. There'll be a random scale between 1 and 2, and they will also be scaling up and down depending on their lifespan. So this is actually looking pretty good. So what if we wanted to have some more fish options, maybe some more colors in order to make this feel a little more vibrant? All we have to do is come over to the mesh renderer here, and under the meshes option, choose the plus button. This will give us another mesh input, and I can drag in another fish that I've already made. Maybe this yellow one, maybe I'll add this white one as well, but you won't see them show up right away because we need to do one more thing similar to the scaling mesh over time option where we had to come back to initialize particles. We also have to do that for the mesh array. So come down here to the mesh renderer array visibility mode here and drop that down and choose random. It's going to give us an error, and that's because it doesn't know what list of meshes to choose from to randomly add to this simulation. So we need to come here to mesh renderer and choose the mesh renderer. So now it's randomly choosing one of those pieces of geometry and simulating that fish. Let's take a look at how it is in our environment. So I'm going to come back over here, switch it to lit mode, and we can see our fish are simulating pretty nicely. They have a very natural flow to the direction that they're swimming. They look like they're making a choice to swim in one direction or the other. The one thing that could make this better is actually animation on the fish itself. You can see these additional fish that I added. I've already set up their material and they look like they're swimming. They have this little animation of them wiggling their fins, and that's all done in the material. So I'm going to show you really quick how to do that for this fish that we just made. Open up the material here. So the way this is going to work is it's going to take the mesh of your fish, and as it moves through space, it's going to apply a sine wave to it. And that sine wave is going to move the vertices of the mesh, and it's going to be doing that through the material. The first thing that we need to do in order to know if the fish is moving through space is get the world position. So I'm going to right click in the empty space and type in world to get world position. Now that we have the world position, we don't actually care about the z-axis. We don't so much care if the fish is swimming directly up or directly down. In order for this effect to look a little more natural, we just want to mask out whether it goes in the x direction or in the y direction. So we're going to use a component mask. So if we drag out here, we're going to choose component mask, and we're going to uncheck everything except for R here, which is going to choose the X value. And we're going to duplicate that node and plug it into the same one. And this one's going to be G. So Y. So we now have X and Y, and we're going to add those together. So now we have a single number that's an addition of the X and Y position in space. Now we're going to multiply that. So we're going to type in multiply, and we're going to create a material parameter that we can adjust later by pressing S, and we'll call this ripple length, and we'll plug that in. And this will adjust the frequency, the length of the ripples by multiplying the coordinates of the world space to make them larger or smaller. And we'll make this 0.02 by default. Next, and this is kind of a trick I'm going to be using here, I'm going to add in the particle color. So we'll right click in the empty space here and type in particle color. And this is going to allow us to add some randomization to the swimming animation by randomization on the particle color. So we're not actually using the color of the particle to affect the color of the fish. That can be done through multiple meshes, multiple materials. Instead, we're going to use that random color on the particle simulation to shift the world space position and therefore shift the swimming animation on each fish, so they're not all swimming exactly the same. Then we'll drag off of there and finally add our sine wave and drag off again and make a multiply. And for this, we want to hold down 3 and create a vector and type in 1 in X and 1 in Y, connect to that. What this is going to do is make sure that the fish only swims from side to side and not up and down. So it's masking out the Z channel in this case. Now we'll finally add a multiply at the end, and this will be what we'll use to adjust the overall strength of the effect. So we'll hold down S and click to make another parameter, and this one I'll call ripple strength. And this one we will make a default value of 2. And finally, we'll plug this all into world position offset and go ahead and hit save. Now you can see our little blue fish that we made are swimming in this little wiggling fish motion, which is wonderful. Now we just need to add that randomization in the particle simulation that I was talking about. So open up the fish sim here, come over to initialize particles, and under color mode here, instead of direct set, we're going to drop this down and choose random range. And now it's going to choose a random range between 0 and 1, which back in our material will add on to this situation here, making the swimming of each fish random. We switch back under the view mode to lit. We can see all of our fish are now swimming with little swimming motions. They're all swimming in various directions, but they all look like they're swimming as a group. This is looking really good. All right, so now the time has come to see if we can use this to simulate 1 million fish and hopefully not explode my computer in the process. Okay, so I've opened my fish up here in this empty environment, and I'm gonna use this to start cranking up the amount of fish and seeing what we can get away with. So I'm gonna open up my simulation again, and the section we're gonna go to is called spawn rate. Under spawn rate, you can see I'm simulating 50, it looks like. So we're gonna try slowly upping this number and seeing how we do. So I'm gonna up it to 100, see what that looks like. All right, that's looking pretty good. Let's try going 500. All right, wow, that's starting to look pretty impressive. I'm gonna actually move my simulation down. We have more room. Let's try 1,000. I'm gonna type in 1,000, hit enter. All right, that seems to be simulating pretty well. Amazing. Okay, let's try a bigger number. Let's try 10,000. Ooh, all right. Still running pretty smoothly for me, which is I'm surprised by. Still running pretty well. This is an incredible number of fish, but let's try 1 million fish. Let's see if this will work. So I believe 1 million is 1,000,000. So that completely crashed my system. If we're going to get that amount of fish on screen and rendered, we're going to need to do some optimization. But I have some ideas and we're going to jump into it real quick. So jumping back over here, I'm going to duplicate the simulation that we made here, and I'm going to call this 1M. I'm going to open that up, and I will go ahead and replace the fish simulation that we've already added into our environment here. And my idea here is that we can take a sprite version of the fish so that we can simulate much more of them. So I'm going to go ahead and delete this mesh render, open up my sprite renderer again, and I have actually already made this material for this fish. So if I open up this material, I'm just using the texture and the alpha. So I'm using the same texture I used on the piece of geometry, but in this case, we're just using a flat plane, and I made it a masked material, and I've plugged the alpha into the opacity mask in the material. This will be a lot easier for the computer to simulate a large amount. So if I come back over to my simulation under the sprite render section, I can drag this new material into the sprite renderer here. And then same as the geometry, we need to come to the alignment and choose velocity aligned. If we come back over here to initialize particles, if we expand the sprite attributes here, I want to make sure that this sprite UV mode is set to unset. That way they're not going to randomly be pointing different directions when they spawn, because I don't want the UVs to be random. So now all my fish are swimming in the same direction here, and this is done as sprites instead of geometry, so I can already tell that there's a lot more of them here. And I'll just come back over to the initialize particles section here and up the sprite size, maybe between 4 and 8 to match the original size I had for the fish. And in order to achieve the random coloring that I had on the other fish, I could come over here to the color mode, come and drop it down and choose direct set. Then in the drop down on the direct set color, I can come and type in random. And what I want to choose is select linear color from array. And now if I expand my color data, I can set a few different colors that the fish could be. So these are all the possible fish's color, and now under the array sample mode, I can just choose random. So you can already see it is making the fish a random color in this range. And the one thing we had to do in the material here, take the texture, desaturate it by a little bit, just to suck a little bit of the color out of the texture itself, and then multiply it by the particle color. And then I personally plugged it into base color and emissive color just to give it a little bit more emphasis. Okay, so now we have a fish simulation very similar to our old one, except in this case, we're using sprites with masked materials instead of pieces of geometry. And I have a feeling this is going to be a lot easier to hit that 1 million number. So let's try it. Okay, coming over to the spawn rate, we're at 1,000 again, and I can come in here, 1,000,000 and hit enter. there we have it. If you found this video helpful, drop me a thumbs up. And if you need more support in terms of training, I have courses, I have a free training below this video, but you can drop any questions that you do have in the comments and I will do my best to get back to you. See you in the next one.